Hello friends, I am Pratima. I welcome you all to my channel. I thank all the subscribers for supporting. So today I have taken a Mass Olympiad challenge. How to prove that all positive real numbers x and y, x power x plus y power x is greater than equals to 2 times of x plus y over 2 raised to the power x plus y over 2. So let a function is defined as fx equals to x power x. Then taking ln both the sides, ln f of x equals to ln x power x, or ln f of x equals to x ln x. Now differentiating both the sides, respect to x, get 1 over fx into f dash x equals to x into 1 over x plus ln x. This is 1 plus ln x. So f dash x equals to fx into 1 plus ln x, or this is equals to fx plus fx f of x ln x. Now again differentiating, with respect to x, we'll get second derivative equals to f dash x plus here fx into 1 over x plus ln x into f dash x. So second derivative equals to f dash x into ln x plus f of x by x plus f dash x. This is greater than 0 because x is positive real numbers. So when second derivative is positive, x is convex function. So when it is a convex function, we can apply Jensen's inequality. x plus f of y arithmetic mean is greater than equals to f of x plus y over 2, or f of x plus f of y is greater than equals to 2 times of f into f of x plus y by 2. What is f of x? This is nothing but your x power x. F of y is y power y. This is greater than equals 2 times this value f of x plus y will be x plus y by 2 power x plus y by 2. So hence proved. Thank you for watching.